on page 10. This is assignment 7, and we're taking notes on quotients and negative exponents. Quotients means division, right? Just like sum means adding and product means multiplication, quotient means division. So let's take a look. Let's say I have something like this. 5 to the 6th divided by, right? This is a quotient, divided by 5 to the 2nd. What does this mean? Let's take a look. What does this mean? This means 5 to the 6th over 5 to the 2nd. Okay, so let's just take a look, right? This is 5 times 5 divided by 5 times 5. Okay, so I could like actually do the math if I wanted, but I'm not going to, I don't need to. Okay, but this, look, this 5 over 5, 5 divided by 5, that's 1. That cancels, right? This is 5 divided by 5, this cancels. So what am I left with here? I'm left with 5 times 5 times 5 times 5, which is 5 to the 4th power. And maybe you could observe that what happened, right, is I had 6 5s on top, and I took away the 2 5s on the bottom. So what I ended up doing was 6 minus 2. The exponent on the numerator, top, minus the exponent on the denominator, right? And if you just need a little reminder, this is the numerator on the top of a fraction, and this is the denominator on the bottom of a fraction. Okay? Let's take a look at another one. Say we have 6 to the 7th over 6 to the 3rd. Okay, now what we noticed is that the rule worked out over here where it was the exponent on the numerator minus the exponent on the denominator. Okay, so we could do, the shortcut here would be 6 to the 7 minus 3. And we can imagine that if I wrote these out, there'd be 7 6s and 3 6s. And I would cross off 3 on the top and the bottom. And what would be left on the top would be 4 6s. Okay. Same works if it's variables. Let's say I had x to the 10th over x to the 8th. It would really suck to write out all 18 of these x's. But I can say, okay, well, if I'm just going to picture there's 10 x's on top and 8 on the bottom, and then I cancel out 8, and what I'm going to be left with on the top is the 10 x's minus the 8 x's, which is x to the 2nd. Okay, so what we notice is this general rule, which is that if I have something to, let's say, the b power over something to the c power, how do I simplify it? The new exponent is going to be b minus c, right? The exponent on the numerator minus the exponent on the denominator. Okay, so that's how you work with a quotient when you have exponents. Now, that leads us into something interesting that happens next. Okay, and take a moment and see if you can observe what's different about this one compared to the ones that I did at the top. Notice here there were more 5s on top, there were more 6s on top, there were more 10s on top. Now look, the larger exponent is on the bottom. Well, let's take a look. Let's draw this out, right? X to the 3rd looks like this, and x to the 5th looks like this. So if I go ahead and just cancel, right, this is x divided by x is 1, x divided by x divided by x. What am I left with? I'm left with x squared on the bottom, and on the top, this is just a 1, right? There's nothing there. This is basically like 1 times 1 times 1 times x squared on the bottom of the fraction. Okay, so, and we just use this 1 as a placeholder on top. So it equals this. Now the other way is I could have said, you know what, I already have a shortcut for something like this. I do the top minus the bottom. The top minus the bottom. Well, x to the 3 minus 5, what's 3 minus 5? 3 minus 5 is negative 2. So here's the deal. If I do it with these two methods, I get two different answers. But here's the thing. These two are the same. X to the negative 2nd power, what does that mean? It means 1 over x squared. It means 1 over x squared. Okay, let's look at it. Let's look at one more example, and then we'll write out the rule officially. And let's just so you can see that this works no matter what. Let's go ahead and do, like, if this is with a number, right? 3 squared. Let me get this up for you. Let's say I have 3 squared over 3 to the 6th. Okay, my rule still works. That's 3 to the 2 minus 6. That's 3 to the negative 4th. Okay, but what I do is I write it like this: 1 over 3 to the 4th. This is how I write my answer, like this. Okay, so, and you notice if I had written out 3 times 3 on the top and 3 times 3 times 3 times 3 times 3 times 3 on the bottom with 6 3's and crossed off, I would have had 4 3's left on the bottom. Okay, so here the rule for this part of the page is that if I have, let's say, something to a negative exponent, what that equals is 1 over x, and then notice it's positive, right? Like this negative 4, this 3 to the negative 4, means it's 1 over 3 to the positive 4. Okay? So this is the rule about negative exponents. This is what negative exponents mean. It means that the power is actually on the bottom of the fraction. Okay? So let's do a few more interesting examples. Let's say I have something like this. Something like this. Now this looks kind of like what we did in our first video way back in assignment number 3, right? This just looks like this. Looks like that. And what did we do? We added our exponents, right? So we can do that, right? We can kind of approach this in 2 different ways. So one way is we can say, okay, well, I'm going to add these exponents together, right? I'm going to add these together. So I'm going to say, okay, this is going to be x to the negative 5 plus 3. And that equals x to the negative 2. And that equals 1 over x squared. So that's one method of doing it. The other way of thinking about this is saying, okay, well, this x to the negative 5th, right? X to the negative 5th, that's 1 over x to the 5th times x to the 3rd. Okay, now what I can do is this is not a fraction, but I can make it to a fraction by putting it over 1, right? And then when I multiply and I say, oh, okay, well, that equals x to the 3rd over x to the 5th, right? So this x to the 3rd over x to the 5th is the same as this. Okay, you can see that x to the negative 5th became this positive x to the 5th on the bottom of the fraction. And then here you could say, okay, well, you could write it out like this. And you can see, oh, this cancels. And what am I left with? I'm left with 1 over x squared. So notice I get the same answer no matter which way I think about it, and no way to think about it is more correct. Okay? But the thing that you need to know is that this is not what you ever write in an answer box. Okay? Because here's the math rule. Make yourself a little box that you won't forget to look at. You need to write answers with positive exponents. Okay, that's the rule. Is it a silly rule? Meh, maybe, but this is how we want our answers, like this, okay? Not like this, okay? And that's just like the rule, like we always write answers in simplest form. We say, meh, this isn't simplest form, this is, okay? Let's do one more example problem, right? Because these actually, negative exponents can get into some pretty interesting stuff. What about this? This is like a little, what does this mean? What does this mean? Okay, and again, there's 2 ways of thinking about this, right? Let's break this into 2 separate fractions, right? We have a to the negative 3rd on top of a fraction, and we're multiplying it times a to the 4th on the bottom of a fraction. Okay, now, what does this equal? Well, we know this a to the negative 3rd. This is a to the negative 3rd over 1. That's just a to the negative 3rd, right? What does that actually equal? That actually equals a to the positive 3rd down here. And I'm just carrying this over. So what is this? This is 1 over a times a times a. This is 1 over a times a times a times a. What do I have total is I have 1 over a to the 7th. Right? I just added these exponents. Okay, another way of thinking about it is I could use this rule from above where I subtract, right? So this is, look, I subtract the numerator minus the denominator. So this becomes a to the -3 minus 4. What does that equal? -3 minus 4 equals -7, a to the -7. And this equals 1 over a to the 7th. Okay, again, same answer. Two different ways of thinking about it. Whichever one you're like, yes, that clicks for me, then do that one. Okay. Notice this rule always works, right? If I have two things that are being multiplied like this, I add the exponents. If I have a quotient, I subtract the exponents, right? That rule always works. And kind of the reason why it works, right, is that I can break these fractions down based on what they mean, and it works out that way.